Hello and welcome to the introduction for this course. What you should know before you take the course: you should have a basic working knowledge of using a computer. You should have a basic working knowledge of using the internet. Who should take this course? This course is designed for beginners to Python, beginners to programming, beginners to web development. What will you learn on the course? We'll start off by installing Python and PyCharm. I'll then give you a quick introduction to object-oriented programming. We'll then create a class and also instantiate a class. We'll go on to modifying the class. We'll learn about class and instance variables. We'll take a look at inheritance. We'll also look at polymorphism. We'll then move on to encapsulation and finally abstraction. The course format is video and the duration is 3 hours long. Thanks for watching. Bye for now. Hello and welcome to this video on what is Python. Python is a general purpose programming language. This means it can be used to write computer programs for various things like games, data science, websites, and so on. Python is also a high-level programming language. High-level programming languages mean that the languages of writing computer instructions in a way that is easily understandable and close to human language. Python is portable, which means we can run Python programs in the various different operating systems like Windows, Mac OS, Linux without any changes. Python is an interpreted language. Python is called an interpreted language because it goes through an interpreter, which turns code you write into the language understood by your computer's processor. Python is strongly typed. Strongly typed languages don't convert data from one type to another type automatically. Python has a huge set of libraries. A Python library is a collection of programs you can incorporate into your own program without writing code for them. Let's take a look at a list of application types you can create with Python. Web applications. These are applications you can access using a web browser. Android applications. These are applications that runs on Android devices like Android phones and tablets. Games. You can create various types of games with Python. Scientific applications. You can create various types of scientific applications with Python. System administration applications. So you can use Python to create applications to monitor various types of systems. You can also create console applications. A console application basically is a computer program designed to be used via a text-only computer interface. Let's take a look at a list of software applications that have been created using Python. So some of these are quite famous and popular. First on the list is YouTube, and then we have Google, we have Dropbox. This program lets you save files to a cloud-based service that you can then access from anywhere in the world. We've also got Reddit. Reddit is one of the biggest open communities on the web. You have a question you want to talk about, something in specific, or if you want to find tons of information regarding a particular topic, for example, gardening or anything, you can just look on Reddit and find related information. Next, we have Spotify. Spotify allows you to listen to ad-free music of your choice. This is a streaming service that allows you to stream music without any advertisement. Finally, we've got Instagram. Instagram is very popular. It has both an app side and also a website as well. These are just a few list items of software that were created using Python. There are so many others, but these are just some few that you may have come across. So that is it for this video on what is Python. Thanks for watching. Bye for now. Hello and welcome to this video. This video is about how to download and install Python on Windows-based computers. To check if Python is installed on your computer, you need to open up the command prompt and type in the following command, which is Python space -- version. I have got my command prompt open, so I'm going to type in the command Python space -- version, and then you press enter. You should get this message displayed saying Python is not recognized as an internal or external command. This proves that you haven't got Python installed. So I'm just going to exit out of this command prompt by clicking on the X, and we have the website for Python. So this is the official website to download Python. The link is displayed on the screen. That will give you access to the download page of Python. So click on the Downloads tab, which is this tab here, and the current version as of the time I am recording this video is Python 3.72. Next, you can click on the button that says Python 3.72 to begin the download. So click on that and the download should begin. So you can see the download here on the bottom left hand corner of the screen. So we'll give that a few minutes to complete the download. The next thing we're going to do is install Python from the downloaded file. To begin the installation, on the bottom left hand corner is the downloaded file. Just click on it to run the Python installation and you'll be presented with this screen. I'm just going to minimize the other screen so we can see the installation screen properly. The setup screen provides some information as to where Python is going to be installed, which it tells you this is where it's going to be installed for me. It also tells you what else is going to be installed. So it says it's going to install idle and it's going to install pip. Next, on the bottom here, we've got a box that says add Python 3.72 path. Make sure you click inside that box to make it checked, and then once you've got that box checked, click on this Install Now button to begin the installation. So click, and that should start the installation. Once the installation is finished, you will get the message saying setup was successful. You can just click to close the setup box. Next thing we want to do is check that Python is installed. To check that we have definitely got Python installed, we need to type in the following command inside the command prompt. So you type in Python space, you do -- version, and then you press enter, and that gives you the current version of Python. You can see it displays version 3.72. So this concludes this video on the download and installation of Python. Hello and welcome to this video. In this video, I will show you how to install Python 3 on a Mac. By default, Python comes pre-installed with all Macs, but the version is quite old. So it comes pre-installed with version 2.7. The current versions of Python being used is Python 3x. So let's open up our terminal to check the version of Python that we have installed. So this is my terminal. So you type in Python, you do a space, -- version, and press enter, and that gives you the current version installed on your Mac. So this is the version that comes pre-installed. It is possible to have both version 2 and 3 installed. So version 2 and 3 can coexist on the same machine. So let's go over to the official Python website and download Python version 3x. X meaning the current version. As of the time of recording this video, the current version of Python, if you go to downloads, it gives you the current version. So the current version is 3.7.2. All right. So to begin the download, just click on the button and it will just drop the download in the download folder. We give it a few minutes to complete. You can see it here. It's downloading. So once that blue bar is completed, we know that it has completed the download. So just give it a few minutes to complete. So once the download is completed, you can see here it gives you a little brown box on the bottom. Just click on the brown box and it shows you what's in there, which is a PKG file. So it tells you open in Finder. So click this to open it in Finder. Now this is what was downloaded. So just double click on it and that will launch the installer. So I'm just going to minimize everything else so that we can have access to the installer screen. So feel free to read through what's on the screen. Click continue. You can scroll through and read through all this. It just gives you some important information about the version. Click continue and you can check out the history and the license if you've got time to do that. Otherwise, click continue and you need to agree to the license agreements before you can progress with the installation. So click agree and click install. It will prompt you for your password. So enter your password and click install. And you can see here it started the installation. So I'm just gonna give it a few minutes to complete the installation. installation is complete. So these are all the stuff that it basically installs. So when you install Python, it also installs all this, the idle and everything else. So I'm just going to exit that at the moment. It's just telling you what it has installed. And then here it tells you the installation was completed successfully. Congratulations, Python 3.7.2 for Mac OS 10.9 or later was successfully installed. So feel free to close the box, and it tells you here, do you want to move the Python installer to the trash now that we've completed? I would say yes, move to trash, because we've done the installation. Next thing is to open up the terminal and let's check for the version of Python. So to check the version of Python that we have installed, we need to type in Python 3 and do space -- version. If we typed in just Python, it will return Python 2, which we don't want. It tells me I've got Python 3.72. If we were to just type in Python and do a space -- version and press enter, it gives you version 2.7. So it's very important when you are trying to develop or create things in Python, you have to use the correct version of Python that you are referring to. For example, if I wanted to do something interactive and I typed in Python to give me the Python shell, and I can do simple maths. I'll do 6 + 6. I press enter. It gives me the answer of 12. Now, if I want to exit, this is called the Python shell. If I want to exit that, I type in exit and parentheses, press enter, and that will exit the shell. If I need to clear my screen, I type in clear, and that clears the screen. Now, if I want to access Python 3 shell, I type in Python and then 3. If you notice, it tells me here Python 3.7.2. So very important to type in the correct version of Python when you are trying to develop or experiment. So again, we can do a simple math. I do 8 + 7. It gives you 15. So we just exit, type in exit, and then the parentheses, and that will exit the Python shell. So this concludes the installation of Python 3 on a Mac. Thanks very much. If you had any problems during the installation, please feel free to let me know. I'll be more than happy to help out. Thanks and bye for now. Hello and welcome. This video is about how to download and install PyCharm on a Windows-based computer. What is PyCharm? PyCharm is a Python IDE. IDE stands for Integrated Development Environment. So PyCharm can be used to create applications that are written in Python. It allows you to write, to run, and test your application from within the IDE. PyCharm is widely used by Python developers. It is cross-platform, which means it can be used on a Windows, a Mac OS, or a Linux-based computer. PyCharm is developed by a company called JetBrains. PyCharm can be downloaded from the link displayed on the screen. To download PyCharm, you need to click on the download button, and that will give you two options. You've got the professional and the community. The professional is a full-featured IDE for development and can be used on a trial basis before you pay. But eventually, after your trial expires, you'll be expected to pay for it. We've also got the community version, which is a lightweight IDE that can be used for Python and scientific development. So that is the option we are going to go for. So I'm going to click on the download button to begin the download for the community. You can see the file here being downloaded on the bottom left hand corner of my screen. Next, let's install PyCharm from the file that was downloaded. So the bottom left hand corner is the PyCharm file that was downloaded. So I'm just going to give it a click to run the installation file. So give it a few minutes and it should pop open a screen. You may get a user account control and just click yes or click run, and that will give you this setup screen. Click next and just accept the destination. It tells you the space required, the space you have got. Click next. All right, and then you can create a shortcut on your desktop if you wish to do so. So you have a 32-bit launcher or a 64-bit launcher. So I'm going to click on that to create an icon on my desktop. You can also update the context menu if you wish to do so, but I'm only going to leave that. You can also update the path variable if you need, but if you click that option, you will need to restart your computer. So I'm going to leave that for now, and I'll click next and I'll click install, and that should begin the installation. So you can see here is dropped the icon on my desktop. So we wait for it to complete the installation. Once the installation has been completed, you get the screen saying completing PyCharm Community Edition setup. So you can either run it by checking the box or you can finish. So I'm just going to click to finish, and that is my icon. So that is it for this video. In this video, I downloaded and installed the Python IDE called PyCharm. Many thanks for watching, and bye for now. Hello and welcome to this video. In this video, I'll be showing you how to download and install PyCharm. PyCharm is a Python IDE. IDE stands for Integrated Development Environment. It's a tool that has all the tools that you need to develop various types of application. We are going to download PyCharm from the JetBrains website. JetBrains are the developers or the makers of PyCharm. So let's go over to the jetbrains.com website, and they also have other tools, not just PyCharm. In this video, we are going to focus on PyCharm. So these are all the IDs they do. So I'm going to click on PyCharm to take us to the PyCharm page. And once you're on the PyCharm page, just click on download. PyCharm comes with two versions. So we have the professional version, which is fully fledged. This is paid for, but it also allows you to try it out for a while. And then we have the community version, which is lightweight, but is completely free. So I will be downloading the community version. So just click on download to begin the download. So we'll give it a few minutes, and that should start the download, and the download should have started. You can see this is the download bar. So once that bar completes to the end, that means it would have downloaded it, and then we can go ahead and run the DMG file, which will enable us to copy the PyCharm application into our applications folder on our Mac. Once the download has completed, you should see that in your downloads folder. So if you click on your downloads folder, it tells you the name of the file that was downloaded. So let's open it in Finder by clicking on this, and that is the downloaded file. So I'm just going to minimize this other screen so we can see the screen properly. So I'm just going to double click to extract the DMG file, and once that is extracted, we should be able to just drag it into our application folder. Just going to double click again to make sure. All right, so it's doing it now. Just give it a few minutes to complete. So it's completed the extraction. We just need to drag this into the applications folder to complete the installation. So I'm just going to drag and drop. It says copying it. So that has completed. I'm just going to exit. Now, if I open up Finder, we should be able to go to the applications folder, and you can see we have PyCharm CE. CE is a community edition. So this concludes this video where we downloaded and installed PyCharm. Thanks for watching, and bye for now. Hello and welcome. In this video, I'm going to show you how you can change the editor theme in PyCharm. I have already got PyCharm opened, and I've got a file in there, and this is the content of the file. This area here is called the editor view. So if I wanted to change the theme basically is the background color here, and it also affects the text, the keywords that you use when you're writing your code. So to do that, you click on File, and then there are two places that you can change your theme. So click on Settings. The first is in Appearance. So go to Appearance, and under Appearance, you click on Appearance, and if you click on Theme, you've got just these three options under that. However, if you come here and under the editor, make sure you've got the editor selected, because that's the bit we are interested in. Under the editor, you click on this option that says color scheme. So click on the color scheme, and within the scheme, if you click on the drop down, you have more options. So just go through each one and then check the background of the editor and see if that suits you. So the one I'm going to change to is called Monokai. I like this theme, so I'll click OK and then go back to my editor. You can see that it has changed. So you can see here the keywords here are now in blue, and any text enclosing quotes is going to be in yellow. So just play around with different themes. If I wanted to go back and try a different theme, I just go to File, I go Settings, and under the color scheme again, say I want to try, say this one that says Twilight. Click on that, click OK, and you can see it gives me a different view, which I don't like. So I'm just going to go back to Settings and go back to my Monokai. So feel free to experiment and also change your theme. So that's it for this video on how you can change your editor theme in PyCharm. Thanks for watching, and bye for now. Hello and welcome to this video. In this video, I'm going to walk you through some basic configuration setup of PyCharm on a Windows-based computer. When you launch PyCharm for the first time after installation, you should get a screen like this that asks you to import PyCharm settings. This usually happens if you've got PyCharm installed previously and you are installing maybe a different version and you've got some settings saved. By default, you should have do not import settings check. So make sure that setting is checked and then just click OK to progress to the next screen. So this is my PyCharm icon. I'm just going to click on it to launch it. So the very first screen you get is the previous screen I showed you, Once you've got that, it then presents you with this screen here. Just click the box that says I confirm and click continue. If you click reject, it will exit, so make sure you click continue, and that will give you this screen on data sharing. Just click don't send. So it's asking you to send some data on your usage. So for now, click don't send, and it then tries to launch PyCharm. So give it a few minutes to launch. Once it launches, we can begin the basic configuration setup. PyCharm is a very powerful IDE for Python, and it has lots and lots of stuff in there. So we're just going to focus on the very basic configuration settings to get you up and running with PyCharm. So this is what you get. Click on this configure option here and click settings, and we just wait for it to come, and then you get the options like this. So this is the settings page. On this page you can change different things. You can see we've got appearance highlighted. This is the appearance interface where you can change stuff. This is the default theme, which is the background color you can see. If you want to change, you can change that. Say for example, I want a darker theme. I'll click on that, and that will give me a darker theme. So if I click apply, you can see the theme has changed to a darker view. So there are different configuration settings here. If you want to do different things, if for example I've got the editor here, the editor is where you write your code. There is an option here called font. If I wanted to change the size of my font, if it tells you here this is the current size, if I wanted to change it, say for example to 20 in size, and it gives me what it will look like. So again, I can accept that, and there is an OK button here. I just click OK to accept that setting. I have not quite finished with the configuration. I need to go back in and click settings, and what I want to do next is set up the project interpreter. The interpreter is very important. It is what interprets the code you write into a code that the machine can understand. So I'm just going to move this up a bit so you can see here. And the bit I'm interested in is this bit here that says project interpreter. So I'm going to click on it, and that will give me this interface. So here you can see here there's no interpreter selected, so I need to add an interpreter. So you can see I've got a drop down here, there's no interpreter. So here in this sign here, I can click add to add the interpreter. So you can see here is giving me some suggestion of where the interpreter could be. I've got Python 3.7, so it's pointing to that directory, so I want to accept that. So I don't want to use a virtual environment, so I'm going to click on System Interpreter. All these settings can always be changed later. So it's got my interpreter selected as that, Python 3.7. What that means is that any code I write will be interpreted in this version of Python. All right, so I'm happy with that. I'm going to click on this OK button, and that will try to load the package list that I can use with the interpreter. So it's giving me, I'm going to be using pip and setup tools. So once I am happy with that, I'll click on the OK button here, and that will start updating the Python interpreter. Once the interpreter has been updated, you're back to the welcome screen here. You got option to create a new project, to open a project, to check out from version control. So I'm going to click this button to create a new project. Click on that, and it gives you the location. This is very important, where your project will be stored. It gives you a default name of untitled. So I'm going to change that untitled, and just type in Python course. You can type in whatever name you like. And then here under project interpreter, I'm going to click on that to expand it to make sure I've got the interpreter I need. It says new environment using virtual environment. I don't want to use a virtual environment at this moment. So I'm going to check this box that says existing interpreter. So it's going to use this interpreter that I have, which points to where my Python was installed. I'm going to click create, and that will create the project. So once the project is created, you get this screen that says tip of the day. This screen pops up every time you launch PyCharm, and there's a checkbox here. If you don't want it to show up, just uncheck it. But I recommend you leave it because it might have some useful tips. You can just close it for now. And this is the interface you get. That's the project that has been created. So I'm going to end this part of the video here, and we'll continue in part 2 where we will create a Python file. Thanks for watching. Bye for now. Hello and welcome to the part 2 of the PyCharm basic configuration setup on a Windows computer. We'll continue from where we left off in part 1. PyCharm has an integrated text editor that allows you to write Python code. So we're going to create a Python file and just write maybe one line of code just to test it out. So to do that, where I've got my project name, that's where I want to create the Python file so that it is contained inside that directory. So I'll right click, and there's an option for new, and there's option for new file. But what's more important, we want a Python file. So we click on that option for Python file. We'll give it a name. I'm going to call it greeting, and it will automatically save that as a Python file. So I'll click OK, and you can see here it's created the file greeting.py inside my project directory called Python course. So this is the editor area. This is where I can now write my Python code. So I'm just going to write just one line of code here. I'll do print, I do parentheses, and I do my quotes. I just say hello world. All right. And that is basically my line of code. This is a complete statement, complete valid code. So to save that, I do a Control and S, or I can come here and do file and just click save as, or just click save. There's an option on the bottom here also that says save all. So there are various ways you can save your work. Now this file here is a file that I can execute inside this integrated environment inside PyCharm. I don't need to leave PyCharm to run this file. So to run this file, there is a play button, but the play button is not automatically activated. So to do that, here on the left where I've got the name of the file, I'll right click, and there's an option to run the file. You can see the name of the file here. I click run, and that will execute inside this area here. This area here, you can see the code here. This line of code I've written here is being outputted inside this area here. This area is called the terminal or the console. Okay, some people call it console, some people call it the terminal. So this is where the code outputs. Another thing to take note is this line here. It tells you the location of the file. So if, for example, I wanted to run this file outside of this integrated environment, I can just browse to the location of this file and then just run it directly in my command prompt or my terminal outside of this PyCharm integrated environment. Another thing I want you to note is that you notice that this play button now is now active. So if I want to run this file on future occasions, I don't need to come here and right click. I can just click on the play button because it's now selected here in the list. If I have other files I create, I will also have them listed. I can go there to make sure they are there and then click on the play button. Also integrated inside the PyCharm, we've got the Python console. Python console is different from the terminal. Is the interactive shell. So if I click on it, you'll see the symbol here. You can see it's the interactive shell that allows you to interact with Python. So the Python console is the Python shell, while the terminal is actually where the code is outputted. The difference within the Python console and the terminal is that with the Python console, you interact. You type in a line of code, you get a response, and so on. Whereas when you are working with the terminal will just output the line of code. For example, here, if I run this code again, all it does, it just gives me the output for the line of code. So there's a key difference between the terminal and the Python console. Let's say I want to run my Python file outside of my PyCharm environment. I can just go to the location of the file, which is indicated here in my terminal. So I've just got it here. So it's on my drive. That's it here. It's got a folder called PyCharm projects. And inside that, I've got the project called Python course, which is that. And inside that Python course, I have got my file, which is called greeting. So if I want to execute or run this file outside my PyCharm, I can do that. I will just navigate to this location. This is it here. I have navigated to the location. It's in this directory here. You can see I've changed directory to PyCharm project, which is this directory here. And then I've also changed PyCharm project is where your projects are stored in PyCharm. So you locate that directory, and inside that directory, you can see I've changed directory to this directory called Python course. And it's inside here that my file greeting.py is. So if I want to run that file inside my command prompt, which is outside the PyCharm IDE, I just come here and type in the name of the file, which is greeting.py, and press enter, and that should execute. You can see it's executed the code here, and that's the same thing it has done when you run it inside the editor. So if I click on play here, it does the same thing here, that I'm able to run inside my command prompt, which is outside the PyCharm environment. So it's very important to know the location of the file in case you want to run that file outside the PyCharm integrated environment. So this concludes the two-part video series on basic PyCharm setup configuration on a Windows-based computer. Note this is just the basic configuration settings because PyCharm is very powerful. There are other stuff you can set up inside it, but to just get you up and running, we've done the very basic. Feel free to go through the help menu inside PyCharm and read through more about other things you can do with it. Thanks for watching, and bye for now. To begin the configuration of PyCharm, you need to open up the PyCharm application from your applications folder. So this is my applications folder and this is PyCharm. So I'm just going to click to launch PyCharm. So when you launch PyCharm for the first time after installation, you may get this message pop up. Just click open, and that should begin the launch of PyCharm. So you may get this option that comes up asking you to import settings. If this is the first time you are setting up PyCharm, there will be nothing to import. So you just click OK and it gives you this licensing agreement. Just click on the box that says I confirm that I have read and accept the terms of this user agreement. Once you've done that, click continue and you get this option here. If you want to send information, just click don't send. So you get this interface about the key map scheme, and you have two options here. I've never used PyCharm before. I used PyCharm before, so I'll leave the default checked and just click next. You can click to skip if you wish to do so and just accept all the default settings. So I'm going to click next, and here it's talking about the UI theme. A theme basically is the background of the PyCharm. If you want a lighter background, this is how it will look. If you prefer a darker theme, which is checked on default, you can leave this darker theme, but you can always go back to change it later. It tells you where you can change it in the preferences, under appearance and behavior, and then in the appearance bit you can change the theme back if you want to switch. For now I'm going to accept the default theme and click next to launch script. Now basically it's asking you to create a launching script. Create a script for opening files and project. If you wish to do so, you can. If not, you can skip it. At this point, I'm going to click skip and accept, skip remaining and set the default, because from now on, it's not really that much to do. You can always go back and change stuff later. So I'm going to click on that, and that would begin the launch of PyCharm. So when you have this PyCharm screen launched, first thing you want to do is configure. So click on this configure button here, and under the configure there is an option for preferences. So click on preferences. Okay, and under preferences there's a lot of things you can do here. Again, if you want to change the theme, that's where you can change it. If you don't like the dark one, you want to go light, just click on the drop down and you have the option to change. There are different things you can also change here. Okay, so you just feel free to look through at your own convenience. But what I want to set up here is the interpreter. Interpreter is basically what we interpret all the code we write so that the computer can understand. So we need to set that up. So click on here where it's called project interpreter. Now there is an option. If you've used it before, it'll give you the options. If you click on the drop down, it will have the interpreter, but because we've just setting this up for the first time, we need to select where the interpreter is. So normally you can select this from the directory where Python was installed. So click on this option here, and that will click add, and that will kind of like give you this option where you can browse to where Python was installed. So it's telling you here you can use the base interpreter, which is located in this location here, which is Python 3.7. Now this I want to use the base interpreter. If you've used PyCharm before, you can use the existing environment. Also here there are other options here. There is inherit global and site packages. So if you want a package that you add to be inherited globally throughout your computer, you can do that. You can make available to all projects. I'm going to leave this option unchecked for now because I don't want to tie down to anything. You can always go back there later. Notice here we've got virtual env selected. If you want to create a virtual environment, so I'll leave that for now. Don't want to complicate things. So click on system interpreter. So this is the interpreter I want the system to use. You can see the interpreter is selected is Python 3.7. I'm going to go with that. I'll click OK, All right, and you can see it's setting everything up. So now we've got the project interpreter. So anytime we are creating a project, it's going to interpret it using Python 3.7, and these are other stuff packages that is going to use as well. So once you're done, just click OK. So that's the interpreter setup. We'll wait for it to finish updating the Python interpreter. Once that has finished updating, it will then give you back the original screen where you'll have an option to create a new Python project. So I'll give this a few minutes to complete. So now that has completed, you back to the original screen here. Now we can go ahead and create a new project. So click on this button to create a new project. You have to give the project a name, and it tells you this is the location where the project is going to be stored. So I'm just going to remove the default name, which is untitled. I'll just call it Python course. All right, and project interpreter, click on this drop down here to select the interpreter I'm going to be using. I will be using this one here, existing interpreter, which is Python 3.7. That's the one I have checked. I'll click create. Okay, and that will create the new project. You will get this welcome screen. Feel free to read through. If not, just close. You get this each time you open PyCharm, unless you uncheck this option here not to show it. So click close, and here basically you've got the project that's been created. Next thing I want to do is create a Python file. So to do that, you just right click on this project that I created called Python course. Right click, go new, and there's an option for Python file. So create that. I'm just going to give it a name. I'll call it greeting, and it will save it with a .py extension because it's a Python file. So I'll click OK, and that will create the file. You can see it's created a file here called greeting.py, which is here. So I'm just going to type in a simple code here. I'm just going to say print, and inside that print parentheses, I'm going to just say hello world. I got a double P here. Need to get rid of one of the P's. All right, so that effectively is a complete Python statement. Just one line of code here to say hello world. So I'll save that. I just do Command and S. If you're on a window, you do Control and S. So now that has been saved. To run that, we've got a little play button here, but that play button is not activated the first time. To activate it, you need to run the file from here. So right click on the file that says greeting.py, and there's an option here that says run greeting. Okay, so click run, and you can see here this area here is called the console. All right, or the terminal. You can see it's outputted this line of code here inside the terminal. This area here is called the terminal or the console, where you can output the code that you run from within the editor. This area here also has the Python console. Python console is different from the terminal. The Python console is basically the Python shell. So if I click on this now, you can see the shell. This is the interactive shell. So if I say 2 + 2 and press enter, it will return 4 because this is an interactive Python shell. So I'm going to click on this X to close the console, and this area is the editor area. See, now that we've run the code the first time, anytime we want to run it again, we don't need to right click on this. We can just go here. You can see the file is highlighted here. If you have multiple files you want to run, you can click on the drop down and then select which one you want to run. At the moment, because we've already executed this file, it's showing up there. So if I want to run it again, I just click on the play button, and you can see here it displays here. Notice also here it tells me the path where this file is stored. So if I wanted to run this file outside of this integrated development environment inside PyCharm, I just go to this location here, grab this file, and then run it from my terminal. All right, so it's very important to know the location of the file. So this file here, greeting.py, is located in this location. So that is it for this video. In this video, we configured PyCharm. We also created and ran a Python file. Thanks for watching, and bye for now. Hello there. Welcome to this video. Object-oriented programming is a very important concept in programming in general. Python and some other programming languages adopt object-oriented programming, which is also called OOP for short. What is object-oriented programming? Object-oriented programming is a type of programming that breaks things into objects that interacts with each other. So if you're trying to solve a problem with programming, you can break the various type of problems into objects that interact with each other. In object-oriented programming, objects are created from classes. A class is like a template from which objects are created. In object-oriented programming, the reuse of code is encouraged and is done through the dry concept. Dry basically means don't repeat yourself. So when you try to engage in object-oriented programming concept, it encourages you to reuse your code, thereby avoiding rewriting code that you have already written. What is an object? An object can be an entity or anything in your program that does something. For example, a noun can be an object. Examples of real-world objects can include things around us, things that we interact with every day. Things like houses, cars, bank accounts, our pets, and so on. So these all can be classified as objects. What is a class? A class is a blueprint. It's a kind of template for creating objects. Classes have properties which are also called attributes, and they are like variables that store different types of data in your program. Classes can also have behaviors. Behaviors are basically functions or methods that does something in your program. Functions inside a class are basically referred to as methods. You can create as many unique objects from a single class. Let me walk you through a basic illustration of how classes and object works. So I've got the image of a car, and that car can be taken as a class. Now this car class can have attributes. The attributes can include its color, the engine type, the door, and the brand. The car can also have methods. Methods are the things the car can do. So it can start, it can stop, it can reverse, it can accelerate. So these are known as methods. So what we have here is a template. So from this template, we can create objects. The objects will be different types of cars. Some of them will have different attributes that they can have from the class template. So when you're creating objects from a class, it is called instantiating an object. All right, so let's say we want to instantiate an object from the class we've got above. So we will first of all give it attributes, and the attributes can include the color, which is red, the type of engine, the number of doors, and the type of car, which is known as the brand. So these attributes for this red car are taken from the attribute of the class. Okay, so the attributes you see here, the red, the petrol, the two-door, and the Porsche, they are regarded as values for the attributes in the class. Now, the attributes for the object can also have methods like start, stop, reverse, accelerate. So you can instantiate as many objects as you want. So I can come here and instantiate another one, and the attributes can include the color, which is yellow, the type of engine could be electric, number of doors could be 4, type or the brand could be Audi. It could also have methods like start, stop, reverse, and accelerate. So this is just a basic illustration of how you create objects from a class. So that's it for this video. In the next video, I'll be walking you through how to create a class in Python. Thank you for watching, and bye for now. Hello and welcome to this video. In this video, we are going to be creating a class. A class can be created with the keyword class followed by the name you want to give your class. The common practice is to make the names of your class to be in Pascal casing. That means make the first letter of your class, the name you're going to give it, make it uppercase. So if your class name has more than one word, for example, my first car, the first letter of each word should be uppercase. That's just a convention that a lot of programmers follow. A class consists of variables that are referred to as attributes. Also, they contain functions, which are behaviors, and functions inside the class are referred to as methods. Classes can be used to model a lot of things in the real world. I'm going to use my PyCharm IDE to create a class. So I've already got my IDE opened, and I've got a directory that I've got all these my Python files inside. So I'm going to create a new Python file by right-clicking on my directory. I go new and click on Python file. I just give it a name. I'm going to call it OOP, OOP, and click OK, and it just appends it with a .py extension. To create a class, you start by typing the keyword class. You do a space followed by the name you want to call your class. So I'm going to call my class instructors. And once you've done that, you add a colon and then you press enter, and that enter indents the code for you. Now you can create variables that are outside a function or a method within a class. Let's say I want to define a variable. I can come here and give the variable a name. I'll call it company name, and I use the equals to give a value to the variable. So I can call it blue lime. So here I have defined a variable on line 2 that is in the class but outside of a class function. A function inside the class is called a method. So let's define a method. To define a method, which is also a function, you type in def, you do a space, and then you do underscore underscore init. This is usually the first method, and inside the parentheses for that method, by default it takes self as the first parameter. You do a comma and then you add other parameters that you wish to add. So at the moment I'm just going to leave it with these two parameters, and then you add the colon after the parentheses and press enter to indent your code. Once you've done that, you then have to create the variables, and the way you do that, inside the method you type in sel self dot, then you give the variable name of the variable is going to be called course, which is this parameter here, and then you set it to equals to itself, which is course. So when you do that, this course basically is a holding variable, so that value, this value here, can change. I'm going to explain what the underscore underscore init underscore underscore is in a few minutes. Let me just create another method first. When you create class and method, make sure that they are indented properly. You can see the indentation structure. If the indentation is not right, Python will complain. So I'm going to create another method. I'll type in def. I'm going to call this print. I'll just say print info. And inside the parentheses is going to take self as the argument or the parameter. And I'll have the colon. I'll press enter to indent it. And then I will write the body of the method. That is, when that method is activated, what do I want the method to do? So what I'm going to do, I'm just going to get it to just print out a text to say you can see I've got a variable here called my company name. So I'm just going to say my company. You can say anything you want there. I can say my company name is, and then I do a comma and refer to the name of my class, which is instructors dot the name of the variable, which is called company name. You see what I've done here? So when this method is activated, this is what it will do. It will print out my company name is, and then it will grab the variable, which is this company name, and display blue line, which is the value of this variable. So let me explain what this method is. This method called underscore underscore init underscore underscore. This method is a built-in function in Python. It is called the initializer. It is used to initialize objects with an initial value. So you can see here, this self.course gives you equals to course. That's what it is doing here. It is initializing the object with an initial value which can be changed later. All classes should have the underscore underscore init underscore underscore method in them. This method is automatically activated or called when a new object is created from a class. I also want to explain what this self parameter is. The self parameter is basically a reference to the current instance of the class. It is the first parameter of any method in a class. It is used to access the variables and the methods belonging to the class. Line 1 here, I define the class by typing in the keyword class. The C is lowercase, and then instructors is the name of the class, and then you have the colon. And line 2 here, I defined a variable. You don't always have to do this, but I just defined a variable inside the class and gave it a value of blue line. Line number 4, I created a method. A method inside the class is also regarded as a function, and this underscore init__ method is basically an initializer that initializes objects with an initial value, and this self parameter here is a reference to the current instance of the class. It is the first parameter of any method in a class. It is used to access variables and methods belonging to the class. So here I've passed in, apart from the self parameter, which is default, I've passed in another parameter, which I'm using the self parameter to reference it to, so that it gets initialized. And here on line 7, I've created another method called printinfo. Again, I passed in this self parameter. And on line 8 here, this is the code that will execute when this method is activated or called. It will just print out my company name is, and then it grabs the variable company name from line 2 and displays the value, which is blue line. Another thing you can do, you can also create a class that has no methods. And the way you do this, let me just create a class and I'll call it pets and add my colon, press enter, and you just type in pass, and that's it. This pass keyword basically means this class has no methods. Hello and welcome to this video. In this video, we are going to instantiate a class. Instantiating a class basically means the process of creating an object from a class. So you can create as many objects as you want from a class. In a previous video, we created a class called instructors. I also created a class called pets that had no methods. I'm just going to get rid of this class called pets. I don't need that. So what I'm going to do, I'm going to instantiate this class called instructors. So I'm going to create objects from the class. And the way you do that is you create a variable and then you set it to equals to the class. So let me start by creating a variable. I can create a variable called e-learning, and I will set that to equals to the class called instructors. Inside these parentheses for this class, we need to pass in a value or an argument for the parameter. So it's got one parameter here on line 5 called course. The __ init__ function, this method, this initializer, initially gave it a value of course just to initialize it. Now we have to pass in an actual value. So inside the parentheses, I'm going to pass in an actual value that will replace this initial value of course. So I'm just going to add, I'll just say Python for beginners. So I'm replacing the original initial value that was set, which is course. So that's basically how you instantiate a class. So I've instantiated a class called e-learning. So let's instantiate another. So first of all, you create a variable. I'll create a variable called BLS, and I'll set it to equals to instructors, which is the name of my class. And inside the parentheses, I'm going to pass in an argument for the variable called course. I'm just going to say Django for beginners. So here I've created two instances. So if you wanted to access the method of a class from an instance of the class, you could do that by typing in the object name, and then you use the dot notation or the period followed by the name of the method. So you can call the method on the new object you have instantiated. So I am going to use this method called print info, which is a method that I defined for my class called instructors. So in order to call the method on an instance of the class, so I've got two instances of the class. Line 10 is called e-learning, line 12 is called BLS. So to access the method, you just type in the name of the instance, which is BLS, and then a dot followed by the name of the method that you are trying to access. So the method is called print info, which is this method here on line 7. So now if I save my code and I play my file, this code on line 14, what that will do, it will execute the print function inside the print info method. So this line 8 here will be executed. So let me press the play button, and you can see here it says my company name is Blue Lime. So what it is doing here, it is executing this block of code on line number 8. All right, so it's grabbing the company name, which is this variable on line 2, and supplied it a value of Blue Lime. That is what it is displaying here in my company name is Blue Lime. So what we've seen here, I've been able to use a method from a class on an instance of the class. You can also access attributes from an instance that has been created from a class. So if you wanted to access an attribute that belong to a class from an instance of the class, you can do so by using the object name followed by a dot notation and then the name of the attribute. So let's say I want to access the attribute called course from my class called instructors. If I want to access that using the instance of the class, I can do that. So I can come here and just type in, I'll say BLS, which is the name of one of my instance. So I'll say BLS dot course. Course is the attribute, which is on line 5. That's what I want to access. So in order to print that on the screen, I need to wrap it around a print function. So I just do my print function. That's the opening parentheses, and that's the closing parentheses for my print function. So if I run this file now, it will print out the value for this attribute called course. When I instantiated the object, I passed in a value of Django for beginners. That's what I am referring to here. So I'm using the dot notation to access the attribute directly. So if I click on play, you can see here it says Django for beginners, and line number 14 here says my company name is Blue Lime. So line number 14 is accessing the method called printinfo, which prints out this. And line number 15 is accessing the attribute called course. So it's accessing the attribute value that I gave. So when I instantiated the class, I passed in a value on line 12 of Django for beginners. That's what it has returned with the print function on line 16. Hello and welcome to this video. In this video, I'll be showing you some ways you can use to modify an existing class. Once you've created a class, you can always make modifications to the class. For example, you can add new attributes to the class. You can change the values of existing attributes. You can also delete attributes. And also you can always add new methods and also make modifications to existing methods. So let me show you an example of how to add a new attribute to an existing class. So this is a class I created called instructors. You can see on line 4 here inside the init method, I've got the self parameter and we've also got the course. And you can see on line 5 here, I've just got just the one attribute. So to add another attribute, I first of all add in the parentheses, I do a comma and just add an attribute called duration. And then here, I'll come here and tab and add an instance to that new attribute. So I create a variable for it. So I do self dot the name of the parameter or attribute is called duration, and I'm going to set that to equals to itself. And this is of course a default value that is assigned to the attribute courtesy of this underscore init underscore method. So now that I've added the new attribute, what I can do, I can now include it in the instance of the class. You can see here when I instantiated the class, I passed in an attribute value for course, which is Django for beginner. Now I need to pass in a value for duration. So I'm just going to do a comma and I'll just add a number. I'll give you a random number. So I make it 8. That will be the value for this attribute called duration. I can also do the same on the instance on line 11. I'll do a comma here and I'll add, say, another duration, give it a value of 7. So if I wanted to access this new attribute value that I've added, I can do so by just doing a print statement. So I can come here and do print, and inside the parentheses I can do BLS, which is the instance dot the name of the attribute, which is duration. All right, so now if I play my file, it should give me the value of this duration that I passed for this instance, which is 8. So if I click on the play button, you can see here it gives me a value of 8, which is the value I have passed in on line number 13 here when the instantiation occurred. You can also change the value of an attribute. So here on line number 13, when I instantiated the class with this variable called BLS, I passed in a value for the course attribute and I gave it Django. If I wanted to change this value, I can do that. All I need to do, I'm just going to tab down I can come here and just type in the name of the instance, which is BLS, dot the name of the attribute, which is course, and I use the equals to sign to assign a new value. So I can just say HTML. Now, if I run this code again, it should print out this line 19 here where it says print bls.course. It will no longer print out Django for beginners. It should now print out HTML because I have modified the value. So let me play that again so you can see. Click on play and you can see here now it's saying HTML, okay, because I have modified the value I originally gave it when I instantiated the class on line 13. You can also delete an attribute. I added an attribute called duration. If I want to remove that attribute, I can remove that using the delete keyword. So I can just come here just before the last print statement. To delete it, I just type in DL and then the name of the instance, which is BLS, which is my object, DL, and then BLS is the instance dot, and then followed by the name of the attribute. And that will delete the attribute. Now, if I try to play this file again, this print statement on line 23 will give me an error because it will not be able to find this attribute called duration because I would have deleted it on line number 21. So let me click on play and you can see here I have an error here. It says attribute error, object has no attribute called duration because I have deleted it. Okay, so you can't see this line 23 because I've deleted the attribute called duration. So I've been able to show you how to make some modifications to an existing class. You can also make modifications to methods within a class. You can add new methods and you can also modify existing methods. Once you have created a class, you can also reuse the code you have created for that class. You can use it in other programs that you're writing by importing the classes. So you can import them into another program you're working on. It's just the same way you can import a module into a program that you're working on. So that's it for this video. Thank you for watching and bye for now. Hello and welcome to this video. In this video, I'm going to show you a very basic table that shows some differences between class variables and instance variables. Instance variables are also known as object variables. Class variables are variables that are defined outside of any method within the class, while the instance variables are variables that are defined inside the methods within the class. Class variables can be accessed outside the class just by calling the name of the class, while object variables can be accessed outside of the class by using the object name. The class variables are not prefixed. The instance variables are prefixed with the self keyword. Modifications that you do on the class instance will affect all instances of the class. So any object that has been instantiated from the class will inherit any modifications made to the class. Modifications that you make to an object is local to that object. It doesn't replicate back to the class. Classes are indented. So when you create a class, you have to make sure it is properly indented with the variables, with the methods, and other things that belongs to that class. With a variable instance, the instances are not indented. So these are just some basic differences between a class variable and an object variable. Thank you for watching. Bye for now. Hello and welcome to this video. Inheritance is one of the key concepts of object-oriented programming. Real-world example of inheritance include ourselves, where we inherit different features and traits from our parents, and they also inherit from their own parents. In Python, inheritance is basically the process that allows us to create a new class and reusing the code from an existing parent class. And this code will contain both methods and attributes of the parent class. The parent class is also called the superclass or the base class. This is the class that is being inherited from. The child class is also called the derived class. This is the class that inherits from the parent class. So it's also referred to as a subclass. I'm going to start off by creating a parent class, just a basic class with first name and last name attributes, and also a print name method. I'm going to be using the PyCharm IDE. I've already got it opened. I've got a directory where I have all my Python files. So these are all my Python files I've been using so far, and this is my directory. So I'm just going to right click on the directory and go new and click on Python file, and I'll just call this file inherit and click OK, and it will append it with a .py file extension. I am going to create a class called person. So to create a class, you type in the keyword class, you do a space followed by the name of the class. I'm going to call mine person, and then I'll add the colon. I'll press enter to indent my code, and I'll create the first method in my class. So I'll type in def space is going to be an init method, so to be underscore underscore init underscore underscore, and then inside the parentheses the first argument it takes is the self, and then I'm going to add a first name parameter and a last name parameter, and I'm just going to press enter to create some indentation. So now I'm going to define the variables for the method. So it's going to be self dot first name, and I'm going to set that to equals to f name, and I'm going to do one for the last name, which would be self dot last name, and that variable we're going to set that to l name as I've defined inside the parentheses of this method here. I'm going to define a method called print name. So I'll type in def, and the name of the method is called print name, and I'm going to pass in the self parameter as the default parameter. I'll press enter, and I'm just going to add a print statement that will execute when the method is called. So inside the parentheses for that print function, I'll type in the self dot the first name, comma, and then we have self.last name. Notice the indentation, so make sure your code is well indented. And the good thing about this IDE is that it does a lot of the stuff for you. Next thing I want to do, I want to instantiate this class called person. So I want to instantiate an object from it. So to do that, you create a variable. So I'm going to create a variable called florist, and I'm going to set it to equals to the class called person. And I'm going to pass in some argument for the first name and for the last name. So first name I'm going to say is Jane, and the last name I'm going to give a value of flowers. So I've now instantiated this class called person. So what I can do now, this method here called print name, I can print it out on the screen just by calling the name of my object, which is florist, and I use a dot or a period and call the method called print name. Okay, and that should print the name Jane Flowers on the screen. So let me save my work and press the play button for my file, and it should print out Jane Flowers. Okay, as you can see on in the output area. So we have created a very basic class, and we have instantiated an object from that class, and also use the print name method, which is a method from this class, on the instantiated object. So I'm going to end this part of the video here. In part 2, we are going to create a child class that will inherit from this parent class that we have created. Thank you for watching, and bye for now. Hello and welcome to the part 2 of the inheritance video. In this part of the video, we are going to create a child class that will inherit from the parent class. In the part 1 of the video, we created a parent class called person, and that had 2 methods, and we instantiated the class by creating an object from the class. So this is what we did in part 1. So now what I'm going to do, I'm going to create a child class that will inherit from the parent class, which is person. So I'm just going to tab down here and just define another class. So I type in class and give it a space, and I'm going to call this class lawyers. And inside the parentheses, I'm going to pass in the name of the parent class. So by doing that, it means it will inherit the methods from the parent class. It will inherit both the methods and the variables from the parent class. Parent class is called person, and you can see here on line 12, I've added that inside the parentheses of this new class called lawyers. By doing that, it forces this class called lawyers to inherit the methods and variables from the parent class called person. So what I can do, I can just type in pass. By this pass keyword basically means that it is an empty method. I'm not creating any methods for this class called lawyers. The fact that I've got the person class here means this class will inherit the methods and variables from this class called person. So anywhere you see this keyword pass, it means that there is no method defined for the function. Lawyers now has the same attributes and methods as the parent class by inheriting the parent class. Okay, so now what I want to do, I want to instantiate this child class or subclass that I've created called lawyers. So to instantiate it, I create a variable. So I'm going to create a variable called happy lawyers. So I'll say happy underscore lawyers. And I'm going to set that to equals to the class called lawyers. This class I've just created. Because I'm inheriting from the parent class, which is person, that means I will inherit the methods and variables of the parent class. So I can just pass in a name. I'll say Jack, and I'll do a comma, and I make the surname Smiley, Jack Smiley. All right, so by doing this way, I'm using the attributes and methods of the parent class. So what I can do also, I can attach a method from the parent class onto this instantiated class. So I can just say happy underscore lawyers, and I do a dot to access the function called print name. Okay, and add the parentheses. So by doing that, I should be able to print out the name of this instantiated object called happy underscore lawyers. So if I press the play button, I will expect two types of output. This line of code on line 10 will print from this instantiated class from the parent. It will print the name Jane Flowers, and then here on line number 15, this instantiated child class will print the name Jack Smiley. So I click on the play button, and you can see here it says Jane Flowers and Jack Smiley. So I've been able to create some inheritance by inheriting properties from a parent class. So this is a class, the child class I created, and I passed in the name of a parent class. By doing that, it inherits the attributes and the methods of the parent class. You see, all I had to do on line 13 here was just put pass. Pass basically means there's a empty method for this function, but through inheritance, it has inherited the properties and methods of the parent class called person. I'm going to end this part of the video here. In this video, we created a child class that inherited attributes and methods from a parent class. Thank you for watching, and bye for now. Hello and welcome. In this video, we are going to add an underscore init function to our child class. When you create a child class without an underscore init method, it inherits all the methods and attributes of the parent class. So if you give the child class its own underscore init method, it will override the init method of the parent class. In the previous video, when we created the child class, we did not give the class any init method. So this is the child class I created called lawyers, and I gave it an empty method on line 13. If we look at the parent class, the parent class has an init method. So it's got underscore underscore init underscore underscore init method. All right. This method here, the fact that the child class hasn't got it, it forces the child class to inherit the methods and attributes of the parent class that it is inheriting. So what I'm going to do now, I'm going to remove this pass keyword. This pass basically means there's an empty method. So I'm going to remove that and give this child class its own init method. So what I'm going to do, I'm just going to cheat a little bit. I'm just going to copy these two methods from the parent class into the child class. So I'm going to replace this empty method where it's got the pass keyword. I'm going to take that out and I am going to paste in the methods I've copied across from the parent class. But what I'm going to do, I am going to change a few things. For example, this method called print name that I've copied across from the parent class, I am going to change the name. I'm going to say, instead of saying print name, I'm just going to say print info. So I've changed the name. I'll leave this print function the same. I'll leave that. And here I will leave the underscore underscore init underscore underscore init. I'll leave that. I'll leave all the variables to be the same as I copied over. But the key thing here is that this child class now is now independent because it's got its own underscore underscore init underscore underscore init method. That means it's no longer relying on the method and variables from the parent class. This underscore underscore init underscore underscore init method, the method is called automatically every time the class is being used to create a new object. By adding this method to the child class, it forces the child class not to inherit the parent's underscore underscore init underscore underscore function. That's what this does. It overrides the init of the parent class. So if I scroll down on my file here, you can see here on line 22 where I instantiated the child class here, and on line 23 here on the child class I was using the print name method from the parent class. You can see here inside the child class I've now got it's got its own method called print info. So I'm going to change that from print name to print info, and then I will run my code and I expect it to print this name out called Jack Smiley. So let me play the file. Click on play. You can see here it's printed out the name Jack Smiley for line number 23, and if I scroll up, it's also printed Gem Flowers. Gem Flowers is for line number 10, which is an instance of the parent class. So we can clearly see that the child class is using its own method. This print info method is a method from the child class that I have used here on line 23. So by using the underscore underscore init method, it forces the child class to use its own methods and attributes. It is also possible to still keep the inheritance of the parents underscore init underscore method by adding a call to the parents underscore init underscore method. So this is how we can do that. So I'm just going to come here inside my child class on line 13. I'm just going to press enter to tab down, and what I'm going to do here, I'm going to add a call to the parents underscore init underscore method. And the way I do that, I just type in the name of the parent, which is called person. Okay, that name of the parent class. So I do a dot and then do the underscore init underscore, and inside the parentheses are passing the self and then passing the other parameters, f name and last name. All right, so by doing it this way, it means I can still reference the parent properties or attributes. So what I'm going to do, I'm going to comment out line number 15 and line number 16 just to show that we can still use the attributes from the parent class. So what I can do here in my instance of the child class, you can see here on line 24, this print info is a method inside the child class. But in the parent class, I've got a function called print name. So I'm going to reference that function called print name. So I'm just going to replace this print info to print name, which is the method in the parent class. Now, because I have added a call to the parents class underscore init underscore method, is going to reference the variables and also gives me access to its methods. So now let me just play this file again, and you should see that you can still see I've got Jane Flowers and I've got Jack Smiley. Okay, so line 24 is printing out Jack Smiley using the print name method from the parent class, and line number 10 of it basically is printing out Jane Flowers, which is an instance from the parent class. So we can see here that even though the child class has got its own underscore init underscore method, we can still access the underscore init underscore method from the parent class just by giving a call, adding a call to that parent class. So that's it for this part of the video. Thank you for watching, and bye for now. Hello and welcome to the part 4 of the inheritance video series. In this part, we are going to be adding attributes to the child class. Since our child class has now got its own underscore init underscore method, we can give it its own attributes. So at the moment it's inheriting the attributes of the parent because I've had a call here on line 14 to the parents underscore init underscore method. So it uses the attributes from the parent. So now I want to add an attribute that will be available only in the child class. So to add an attribute, I'm just going to tab down, and the name of the attribute is going to be case type. So where I've got the init method in the child class, I'm just going to add it as a parameter first. So I do a comma and I'll give it a parameter of case type. All right, and then now that I've added it, I can come here and create the variable for it. So I'll do self dot case type, and I'll set it to a value of case type. So now that I've added this property called case type, this parameter, what I can do when the instance of this class is referenced, I can pass in a value or an argument for this case type parameter. So if I go down where you can see here on line 24 to on line 25, where I instantiated the class, the child class. The child class is called lawyers. So I instantiated it on line number 25. And when you instantiate, you pass in some arguments or values. So what I'm going to do now is now add another value for this case type parameter. So after the last name, I'll do a comma, and I can just say maybe the case type is criminal. All right. So now that gives it the value for the parameter case type. So if I wanted to access the value of the case type, I can just do a simple print statement. I can do print, and inside the print function, I can reference the instance, which is called happy underscore lawyers, and I can add the case type attribute with a dot and just type in case type, and it should give me a value because I've already passed in a value here of criminal. So when I do a print statement, it should print out criminal. So I'll do a play here to play the file. You can see here is printed out criminal, which is what I've asked for on line 28. I'm just telling it to print out what the case type is. So that's the value for the case type attribute. You can also add methods to a child class. So in the child class here, I copied a method from the parent class called print name, but just changed the name from print name to print info. So what I can do, I can modify this method inside my child class. So I can just say here, I'll just add, rather than say print self.first name, I can change it. I'll just say hello. I'll add a print statement that says hello. Type in the hello, and I'll say my name is, and I'll add the closing quote. So now I have modified this print info method to print hello, my name is, and then it grabs the value of the first name variable and the value of the last name variable. So it will say hello, my name is Jack Smiley. So here on line number 26, I could change the name of this print name method, which is from the parent class, to print info, which is the method inside the child class. So if I do print info, and what that should do, it should now print out this print statement on line 21. So let me save that and play the file. So I'll click on the play button, and you can see here it says, so it's printing out. I've got 3 print statements here. So line number 10 is the first one. So it's printing the name of this instance, which is Jane Flowers. And then if I go to the next statement, which is on line number 26, so it's printing out this print info method, which says, hello, my name is Jack Smiley. And then number 28, line number 28 is printing the case type, which is criminal. So we can see here, I'm able to reference the individual method of the child class, which is independent of the parent class. Just a quick note, if you add a method in the child class that has the same name as a method in the parent class, the inheritance of the parent method will be overridden. The child class takes precedence. Okay, so take note, when they have the same method names, the method name in the child class will override that of the parent. So that's it. This concludes the video series on inheritance. Thank you for watching, and bye for now. Hello there. In this video, I'm going to introduce you to polymorphism. What is polymorphism? Polymorphism basically means the ability to take or have multiple or various forms. A typical example of polymorphism is a phone. A phone has just one name but has many functionalities. You can use a phone as a phone. You can also use it as a camera and also as an MP3 player. So this is just a basic example of a polymorphic form. Another example of polymorphism is a word. You can have a word that can be used in different situations but means different things. For example, you could say he is wearing a watch. That is a noun. The watch part of it, of that sentence, is a noun. You could also say watch your actions. So if you use it in that context, it becomes a verb. So the same word but different meaning depending on the context in which it is used. In Python, polymorphism allows you to define methods that are present in the parent class. It allows you to define the same method with the same name in the child class, but the methods in the child class will do different things. So you can define methods from the parent and the child class to have the same name, but they do different things. So that again is an example of polymorphism. I have got my command prompt opened on a Windows computer. I want to access the Python interactive shell. To do that, I just type in Python and press enter. So let me show you an example of a polymorphic built-in function. So we have a function called print and also a function called len. So I'm going to wrap the len function inside the print function. So inside the len function, I'm going to pass in a text. I'm just going to say hello, and I'll close the parentheses and then close the other parentheses. So what's happening here is that I'm using the len function, which is enclosed inside the print function, to print the characters of the text hello. So if I press enter, it gives me the character of 5. Next thing I'm going to do, use the same functions to access the length of a list. So I'll do print, and inside the parentheses I'll pass in the len function. I'll do my opening parentheses and then add a square bracket to add the members of the list. First item, I'll make it 20. Second item, I'll make 40. Third item, I make 80, and then I'll close the list and then close the parentheses for the length function and the parentheses for the print function. So if I press enter, you can see it's giving me a value of 3, which gives me the items in the list. So you can see I've got two functions, the same function, but behaving differently. When used on a string, it gives you the character length of the string. When used on a list, it gives you the item in the list, the number of items in the list. So this is an example of polymorphism. So that's it for this video. In the next video, we will create some polymorphic functions and methods. Thanks for watching. Hello there. Welcome to the part 2 of the polymorphism video series. In this video, I'm going to use the PyCharm IDE to illustrate some more polymorphic forms. So to do that, I'm going to create a new Python file. I've already got a directory here. I'm just going to right click on the directory and go new and click on Python file. I'm just going to call it poly and it will append it with a .py extension. So that's it there, and that's it listed here. So I'm going to start off by creating a basic polymorphic function. So to create a function, you type in def space, you give the function a name. I'm going to call this add numbers, and inside the parentheses I'm going to pass in 3 parameters. First one will be A, second will be B, and the third will be C. I'm going to give the third a value. I'm going to set it to 1. Okay, and then I will add my colon, press enter to create some indentation, and I want this function to return something. So I'm going to say return the value of A plus the value of B plus the value of C. So I'm going to use the print function, the built-in print function, to print out some numbers. So I'm going to say print, and inside the parentheses for the print function, I'm going to pass in the name of my function, this function here called add numbers. And that function takes in 3 parameters. One of them has already been set. So inside the parentheses for this add numbers function, I'm going to pass in some variables. I'll pass in 8 and I'll pass in 9. No need to pass in a third argument because the parameter C has already been given a value. So I'm only providing an argument for the parameter A and B. So I'm going to save my file and just click on play. And you can see here it's giving me the value of 18. So it's added the value of A, which is 8, plus 9, plus 1, which is the value of C. Because even though I've not specified C here, I've already given it a value. So this return statement on line 2 is what is being used to do the addition. So I can use the same method, again, the same function, and get a slightly different result. So I can come here and do another print function, and inside that print function, I'll pass in my function called add numbers. And inside the parentheses for that, I'm going to pass in, say, the same values. I'll say 8, 9, but this time I'm going to change the value for C. In the first print here on line 4, I didn't add the value for C because I'd already given it 1 here. But in this print function on line 6, I am changing the value of C from 1 to 4. So these are the same function but behaving differently. So I'm going to save that and click on play, and you can see here it has now given me 21. This 18 here is for the print statement on line 4. This 21 is for the print statement on line 6. So again, the same type of function, but I have called, when I call the function, I changed the value and it gave me a different output. So that is an example of polymorphism. The next thing I want to do is create a polymorphic class with methods. So to begin, I'll type in class to create a class. I'm going to create a class. I'm going to call it UK and add the parentheses and then add the colon, and I'll press enter to give me some indentation. Now inside this class, I'm going to create 2 methods. So to create a method, you type in def space and then give the method a name. I'm going to call it capital underscore city. That's going to be the name, and inside the parentheses is going to take in the parameter self as the default. So if I press enter, it will indent that line of code. So now I need to specify what will happen when the method capital under city is called. So I want it to print something. It's going to print, and inside that is going to say London is the capital of UK. So when this method is called, I expect it to print out this text. I'm going to define another method inside this class. I'm going to call it language. So the name of the method is language. Again, I'm passing the variable called self and press enter, and then I'll add the function or what will execute when the function or method is called. So I'll type in print. So when this method is activated, I want it to print this text that says English is the primary language. What I'm going to do, I'm going to create another class exactly like this one, but it's going to be a different name. I'm going to create a class called Spain. So I'm just going to copy everything here and just change a few minor bits and pieces. So I've copied the same class over. I just want to make some changes. Instead of saying UK there, I'm going to make that Spain. Here I'm going to say where it's got London is the capital. I'll just say Madrid. You can see here both functions here have the same type of methods, but the methods are doing different things. For the methods inside the Spain class, it will print Madrid is the capital of, should be Spain, not UK. I need to change that. Okay. And then the language should print Spanish is a primary language. Then if I move on to the UK class, it prints London is the capital of UK, English is a primary language. So they both have the same methods, but the methods are doing different things. Again, this is an example of polymorphism. Hello and welcome to the part 3 of the polymorphism video series. In the previous video, we created 2 classes that had the same method names. So the first class was called UK. It had 2 methods, capital underscore city and language. And I had another class called Spain, which had 2 methods that has the same name as the methods in the UK class. So what I want to do, I want to instantiate both classes. I want to create an instance, so create object from the classes. So first I need to create a variable. So I'm going to create a variable called queen, and I'll set that to equals to the class called UK, and that will instantiate that class. Next, I'm going to add a method to this instance. I have a method called, so I'll go queen. To attach a method to an instance, you use the dot. So queen dot, I've got a method called capital city. So this method now is now being attached to the instance of the class called UK. So I'm going to do the same for the class called Spain. I'm going to create a variable called Zara, and I'm going to set that to equals to the class called Spain, and that will instantiate the class. Again, I want to attach a method to this class, so I call the instance by its name and then use the dot to attach the method. So this method called capital underscore city is a method that is present both in the class called Spain and in the class called UK. All right, so I've now created instances of both classes. So both objects or both instances of the class are using the same method names, but in a different way. To show how Python can use each of these different class types in the same way, we can create a for loop that will iterate through a tuple of objects. And once we've done that, we can then call the methods without being concerned about which class type each object belongs to. So let's go ahead and do the for loop. So I can come here and just say for country in, and then I'll pass in the instance queen. That's one of the instance of the UK class, and then Zara is the instance of the Spain class. Okay, so I'll add my colon, press enter. So I'm saying for country in the instance of queen and Zara, I'm going to say country dot capital. I'm using the dot now to call the method called capital city, and then I'm going to use the country again to call the other method called language. All right, so I've got a method called language. So here now I'm using the for loop to iterate through the instance and then access the methods. So it's going to treat them as a tuple, but it doesn't really care which class they come from. So it's just getting access to their methods and iterating over the tuple list. If I play my file, you should see the output from the for loop. It will loop through the instances and then print out the capital city and print out the language. So it's going to be accessing the methods from each of the classes. So I click on play, and then you can see here in the output is printing out, going through, prints out London as a capital, Madrid is a capital, and so on. Okay, so it's just looping through and printing out the responses or the value for each of the methods that have been specified in each class. So this is accessing this print and this print here from both classes. You can also create a function that can take any object as a parameter, thereby allowing for polymorphism to occur. So let me create a new function. So I'll type in def and I'll call the function Europe, and I'm going to pass in EU as the parameter, and I'll press enter. And what I can do, I can now reference that parameter. So I'll do EU dot. I will use that dot to access a method from the other class. So there's a method called capital underscore city, which belongs to the other classes. So you can see this class Spain has this method called capital underscore city. So you can see here, I'm accessing that from this new function I created here called Europe. So what I can do, I can call this function called Europe and pass in the instance of the other classes that I've created. So I can come here, I've got an instance called Queen from the UK class and an instance called Zara from the Spain class. So what I can do, I can call the function which is called Europe and pass in this instance called Queen and this instance called Zara. So let me just tab down and do that. So I'll say Europe, which is the name of the function I created, and I'll pass in the instance called Queen, and I'll tab down, I call Europe again, and I'll pass in the instance called Zara. Also, line 35 has been commented out. That will not execute. That is a single line comment. This here is a multi-line comment. All right, so line 29 also will not execute because I put a comment on it. So in the function definition of this function called Europe, I inherited this capital underscore city method from here. There's a method called capital underscore city. So here, where I'm passing in the instance Queen, which is an instance from the UK class, and this is Zara, an instance from the Spanish class, they will print out, if I play my code now, it will print out the capital city of both instances, okay? Because I've only got the capital underscore city method specified. So let me click on the play, and you see here it says in the output, London is the capital of UK, Madrid is the capital of Spain. I've not specified any other method. That's why it's only displaying the method I have added to the function. And you can see here, line 33 and 34 is what I'm using. I'm passing in an object, which is an instance, into this function called Europe, thereby creating some polymorphism with the function called Europe. So that's it for this video series on polymorphism. Thank you for watching, and bye for now. Hello and welcome to this video. What is encapsulation? Encapsulation is the process of restricting access to methods and variables in a class in order to prevent direct data modification. So it prevents accidental data modification. Encapsulation basically allows the internal representation of an object to be hidden from the view outside of the object's definition. So a class is an example of encapsulation because it encapsulates the data it contains from its methods and its variables. Public methods and variables can be accessed from anywhere within the program, while private methods and variables can be accessed only within their own class. With some other programming languages, you can mark an object private or public by using the private or public property or key. Python does not have those types of attributes. In Python, in order to make an object private, you have to prefix the name of the object with double underscore to make it private. To begin, I am going to create a class and going to add 3 methods in the class. So I'm going to be using my PyCharm IDE. So this is my IDE, and I've already got a directory where I have all these Python files. I'm just going to create a new Python file. I'll right click on my directory and go new and click on Python file. I'm just going to give it a name. I'm going to call it ENCAP for short and click OK, and that will be appended with a .py extension. So you can see it here, and also it is listed here. So I'm just going to create a simple class and add 3 methods to that class. To create a class, you type in the keyword class, followed by a space, and then the name you want to call your class. I'm going to call mine cars, and I'll add my colon and press enter to indent. I'm going to add an init method, so I'll do def space underscore underscore init underscore underscore, and inside the parentheses for that init method we'll have the self as a parameter, and I'll add 2 other parameters. First one's going to be speed, and the second is going to be color. All right, and I will then press enter to provide some indentation. So now I have to define some variables for this method. So the variables will be what I've specified in the parentheses, which is the speed and the color. So you do self dot speed, and we set that to equals to speed, and we press enter and do the same for the second parameter, which is color. So we'll do self dot color, and we set that to equals to color. So I'm going to create another method. Notice the indentation has to be on the same line, is very important. So I'll type def to begin, and this method is going to be called a set method. So I'll call it set underscore speed, and the objective is to use this method to set the speed if I need to. So inside the parentheses for this method, it takes in the self parameter by default, and I'm going to give it another parameter which is going to be value. Now I'm going to just press outside the colon and press enter to indent my code, and I'm going to create the variable for that method. So to do that, I do self dot speed, and I'll set that to equals to value. So the objective of this method is to be used to change the value of the speed variable. The next thing I want to do is create another method. I'm going to call this method get underscore speed, and this method is going to be used to get or retrieve the speed. So again, def to define the method, I type in get underscore speed, and this will just take in the self as the parameter, and I want this to just return the value of the speed. So I'll type in return, and it would be self dot speed. So whatever value is been set for the speed, this method will be used to retrieve that. I'm going to end this part of the video here, and we will continue in part 2. Thank you for watching. Bye for now. Hello and welcome to the part 2 of the encapsulation video. In the part 1 of the encapsulation video, we created a class that has 3 methods. So what I'm going to do now, I'm going to instantiate the class. So I'm going to create 3 objects from this class. So the first object is going to be called a Ford, and I'm going to set it to equals to the class, which is called cars, and the class has 2 parameters or variables, the speed and the color. So I've got to pass in argument for the speed and for the color. So for the speed, I'm just going to say 250. I'll do a comma. For the color, I'm just going to say green. All right, that's the first. And I'll tap down and I'll create another instance. I'll make this one a Nissan. I'll set this to equals to the class. And for the variable, this one, I'm going to give it a speed of 300. I'll do a comma. And the color, I'm going to set this one to red. I'm going to create one more. I'll make this one a Toyota. And I'm going to set that to equals to the class called cars. Okay. Be careful with your instantiation. The has to be in the right case. So if I defined it cars uppercase and try to instantiate with the lowercase, it will not work. So inside the parentheses, I'll give this one a speed value of 350, and I'll make this one the color of blue. So now I've been able to instantiate this class called cars. I've created 3 objects from it. So at the moment, there is no encapsulation in place, so I can directly change or make modification to variables or the method. So let's say I want to, here when I instantiated the object or the class, I gave it different values. For example, this Ford here, when this was instantiated, I gave it a speed value of 250. Here I've got a parameter called speed. So if I wanted to change the value of the speed after the instantiation, I can do that by using the name of the instance and the method. I've got a method here called on line 6 called set_speed. So to access that method, I just type in the name of my instance, which is Ford, and you do a dot or a period and type in the name of the method, which is called set_speed. All right. And then in parentheses, I can assign a new value. Say if I make it 450. All right. So what I've been able to do here, I've been able to change the value of the speed variable that I set when the object was instantiated. When I instantiated the object on line 12, I gave it an argument value of 250. On line 16 here, I'm changing that using the set_speed method on line number 6 to set a new value for the speed. Now, because there's no encapsulation in place, I could also access the speed variable directly without the method and then change the value. So I can come here and just say Ford, which is the name of the object, dot speed. Speed is the name of the variable, and I can just set that to 500. So I'm able to do all this because there's no encapsulation in place. So what I can do, I can do the print method and access this get method on line 9 to display the speed. So I'll do print, and inside my parentheses I will reference the object, which is Ford dot the get speed method, which is get underscore speed, and I'll add the parentheses for the method, and that should print out the speed. I also want to print out the color, so to do that I can just do print, and inside the parentheses I reference the object or the instance. I do a dot to access the variable color. All right, don't forget, when the object was instantiated, or when the class was instantiated on line 12, I gave it a color of green. So that's what I'm asking it to print on line number 12. So let me play my file. I click on the play button, and you can see here it's giving me the code for line 20, which is the get speed. The get speed method gives us a speed of 500. Line number 22 here gives me the color green. So if you notice here, we changed the speed to 450 using the set speed method, and then on line number 18 I changed the speed again directly by accessing the variable and changing it to 500. So I'm going to end this part of the video here, and we will continue in part 3, where we will implement some encapsulation. Thanks for watching, and bye for now. Hello and welcome to the part 3 of the encapsulation video. In this video we are going to implement some encapsulation. So far within our class, the methods are all public, so they can be accessed. Also, the variables inside the methods can be accessed from anywhere within this file. So what I want to do now is restrict some of that by enforcing encapsulation. In Python, to make a variable or a method private, you have to append it with double underscore. So here inside this method here, this variable called speed, I'm just going to append it with double underscore. So I'll do underscore underscore. That will make that variable private. I'm going to do the same with the color variable. I'm going to do underscore underscore. That makes that variable private. In this second method here, the set speed method, I've got this variable called speed, so I'm going to append it with double underscore. So I'll do underscore underscore. That will make that private. And then with the get method, I've also got the speed here. So again, I'm going to give it double underscore underscore underscore, and that makes it private. So it will now be difficult to directly access the variable outside the class. So now that we have some encapsulation in place, it will be very difficult to change the value of the variable directly outside of the methods in the class. So if we look down here, this is where the class was instantiated, and here where we've got Ford.setSpeed, we set the speed using the set underscore speed method, which is this method on line 6, and we were able to set the speed to 450. Line number 18, I was able to access the variable directly to change the value of the speed. I can't do that anymore now that I've got encapsulation in place, because the variable speed now it's got double underscore, which means it's now private, so I cannot access it outside of the method. So this code on line 18 now will not work because it cannot access that value anymore. So also what I need to do is just change some of the values. You can see here on line 22, I was able to print the color directly. Now I've changed the color to a private variable with double underscore. So I need to add here, I need to add the double underscore, but even with the double underscore being added here, I will not be able to change the value of this variable, this color here. Neither will I be able to access it because it's now private. So if I try and play my file now, you should see some error. You can see here it's telling me attribute cars, object has no attribute color because it's private, it cannot see it. All right, so this line 22 is what it's complaining about. Now let me comment out line 22, and if I do a print, this one here, print this comment on line 20, this code, it will not give me this speed of 500 because this will no longer be accessible. It will give me the speed on line 16 because this set underscore speed method is inside the class. Okay, and that's what I use to set it to 450. So let me save and play that, and then you can see. All right, you can see here it's giving me 450 as a speed. It's completely ignored the line 18 where I set it to 500 because it can't access it anymore. That variable is now private. The only way to change the variable values is by using the set underscore speed method. Now if I want to change the value of this color variable, I would have to set up another method, a set method for the color and a get method for the color, just as I have done for the speed variable. So I'm going to leave you to do that. Just replicate what I have done for the set underscore speed and the get underscore speed. Just do the same, but for the color, because that's the only way you can change the value of the color now that I've made it a private variable. So now I can come here and change the speed again. I can only do that using the set underscore speed method. I can't use the variable directly. I can't change it directly because of the encapsulation. So I can come here and change the value of the speed. So I'll make it, let's make it 750. All right, and that should work because that method is inside the class. So if I click on play, you can see here it's worked. It's giving me the value of 750. So the get and the set method is what you can use to change values when there's encapsulation in place. So here on line 18, because I've made the variable speed private, I need to add double underscore, but this will not make any difference. I still will not be able to change this. So if I make this, for example, 800, it will completely ignore that and go for the one I set using the set speed method. So let me just play that and you will see. So I click on play, you can see it's ignored it. A variable that is encapsulated cannot be accessed outside of the class or method. So only the methods within that variable can be used to access it. So the only way I can change the speed is to use the set method, and then I use the get method to retrieve the speed. Encapsulation gives you more control over the degree of coupling in your code. Okay, so it allows a class to change its implementation without affecting other parts of the code. So that's it for this video. This concludes the 3-part video series on encapsulation. Thank you for watching, and bye for now. Hello and welcome to this video. What is abstraction? In terms of data, abstraction refers to providing only essential information about the data to the outside world, thereby hiding the background details or implementation. So in a nutshell, abstraction is used to hide the internal details and show only functionalities that are required. An example of a real-life abstraction is driving lessons. The instructor does not have to teach you how the engine works, just focuses on how to drive the car. Other examples include things like electricity. You only know how to switch the light on, but you don't necessarily see the internal wiring that makes that possible. What are abstract classes? Abstract classes are classes that contain one or more abstract methods. Now, abstract classes cannot be instantiated. That means you cannot create an instance object from an abstract class. Also, an abstract class will require subclasses in order to provide implementations for the abstract methods. Subclasses of an abstract class in Python are not required to implement the abstract methods of the parent class. What is an abstract method? An abstract method is a method that is declared but contains no implementation. So in order to provide implementation for an abstract method, you will need to have subclasses to provide that implementation. To begin, I am going to create a parent class and also create a subclass that will inherit from the parent class. I'm going to be using my IDE, which is PyCharm. So I've already got a directory in my PyCharm. I'm just going to right click and create a new Python file. So I'll right click and go new and click on Python file. I'm just going to call it abstract, and it will append it with a .py extension. So I'll click OK, and you can see here that's the file there, abstract.py. So the first class I'm going to create is going to be the parent or the base class. So to create a class, you just type in class, do a space and give the class a name. So I'm going to call this shape. All right, and just add a colon and I'll press enter to provide some indentation. So I'm going to define a couple of empty methods. So the first one is going to be def. That's how you define a method inside a class. So a function inside a class is called a method. So I type in def and then type in the name for that method, which is I'll call it area. And inside the parentheses, I will just add the self method and add the colon. So I'll press enter. I'm just going to add a parse, which means there's not going to be any implementation for that method. It's an empty method. That's what this pass means. So I'll tab and I'll create another method. So I'll type in def space, I'll type in perimeter, and then again I'll add the self and the colon and press enter to tab. I'm going to make this one also an empty method, so no implementation will be done there as well. Next thing I want to do is create a subclass that will inherit from this parent class. So again, I'm going to indent. The indentation has to be on the same level. So you can see here, when I'm creating a class, I have to indent on the same level as the other class. So I just type in class, I do a space, and then give the class a name. I'm going to call this one a square. All right. And then because I'm going to inherit from the parent, I'm going to pass in the name of the parent class because I am inheriting from that class. So I just add my colon and press enter to provide indentation. So inside this subclass, I'm going to add an init method. So I'll type in def underscore init underscore, and I am going to add inside the parentheses for that init method, I'm going to add a parameter called side, which we refer to the side of the shape. I'm going to press enter, and then I'll add the variable. So I'm going to say self dot side is equals to side. The next thing I want to do is instantiate the parent class. So to do that, I'm just going to create a variable called my shape, and I'm going to set that to equals to the parent class, which is called shape. All right, so this here has created an instance of this class called shape. So I'm going to play this file and see if there's any error messages. So if there's no error messages, that means the shape was instantiated okay. So I click on play. You can see here it's got abstract, which is the name of this file. When I click play, you can see there's nothing here. There's no errors, which means that the class shape was instantiated properly. Line 11 here shows the instantiation, which means I've created an object from the class called shape. So far, what has happened inside this file here, inside this class is here, is called just inheritance. So no abstraction has occurred, because you can see here on line 11, we were able to instantiate the instance of the class. Also, we are not required to implement the class, the methods for the parent class in the subclass. So no implementation of the parent methods inside the subclass. So no abstraction has occurred. With abstraction, it will not be possible to instantiate. I'm going to end this part of the video here, and we'll continue in part 2. Thanks for watching, and bye for now. Hello and welcome to the part 2 of the abstraction video. In the part 1 of this video, we created a parent class and also a subclass that inherited from the parent class. Python does not on its own provide abstract classes. However, Python comes with a module which provides the infrastructure that allows you to define abstract classes. And the name of the module is called ABC. ABC stands for Abstract Base Classes. So before you can use the module, you have to import it. So I'm just going to tap down, and right at the top here on line 1, I am going to import the module. So to do import, you type in from, and the name of the module is called ABC. So I'll say from ABC, I'm going to import ABC in capital case, and then space, and then you type in abstract method. Next thing we want to do, we want this class, this parent class called shape, to inherit from the module ABC. So just here before the colon, we just add the parentheses, and inside the parentheses we type in ABC, which stands for Abstract Base Classes. In order to implement abstraction, we are going to use a decorator with the module. A decorator basically is a design pattern in Python that allows you, the user, to add new functionality to an existing object without modifying the object's structure. So I'm going to add abstraction to the two methods inside the parent class. So to do that, we're going to use the decorator, and the symbol for the decorator is the @ sign. So above the first method, you do the @ sign, and then you type in the abstract method in lowercase. You type in abstract method. Okay, and by doing that, that will create abstraction in the class. If you have several methods in a class, if just one of them is got the abstract method, it will make the entire class abstract. All right, so that's the first abstraction to this method called area. I want to do the same to the other method. So again, I add a decorator using the @ symbol, and then type in the abstract method, and just by doing that, it makes those methods abstract and also creates abstraction in the class. In the part 1 of this video, I instantiated an instance of this class shape. You can see here, this is a variable, and I instantiated it with this class called shape. Now that I have added the abstract method, it makes the class an abstract as well. So with an abstract class, you should not be able to create an instance. So if I run this code again, I am going to get an error for this line 14 that I have instantiated in a previous video. So when it was instantiated, there was no abstraction. Now that I've abstracted the class via the methods, I expect to get an error. So if I play the file again, you can see here telling me here my shape, this variable my shape has got an error. It's saying type error, can't instantiate abstract class shape with abstract methods. Okay, that I've got two abstract methods. One is called area and the other is called perimeter. So with abstraction, you have to implement the method in the subclass. So whatever method you have in the parent class, you have to implement it in the subclass because of the abstraction. If I try to instantiate this subclass square, I will expect to get an error as well, because the square class has inherited from the parent class, which is called shape, and the parent class has already got abstraction implemented courtesy of its method. So let me just try, see if we can instantiate an instance of the square class. I expect to get an error, so I'll do my shape or my square. This is a variable I'm creating called my square, and I'm going to set it to equals to the square class. Okay, so now if I'm just going to comment out line number 14 so that we can see the error that it gives me for line number 16. So now let me play the file. You can see here I get the same error here. It's referring to my square, which is this line 16. It's telling you here type error, can't instantiate abstract class square with abstract methods area and perimeter. So it's referring to, because of the inheritance, this class here is inherited from the parent class, so it can't access the methods because of the abstraction, hence it can't create an instance. So to get around this, we have to provide implementation of the parent method inside the subclass, and this should get us around the abstract trap. So what I'm going to do now is create an implementation of these two methods inside my parent class. I'm going to create that in the subclass. So I'm just going to tab down in my subclass and just make sure that the indentation level is the same. Okay, if not, you get an error. So I'm going to implement the methods I have in my parent class inside my subclass. So I type in def to define the method, and the first method is called area, and I'm just going to, inside the parentheses, pass in the self and just tab, and then I want to return something, so I'm going to return the self dot, and I'll do underscore side, which is the variable, and I'm going to multiply that by the self dot underscore side. So what this is saying basically, when this value is returned, whatever value is supplied, it will multiply it by itself. All right, so that is the first method implemented. I'll now tap down and define the method for the perimeter. So I'll type in def to create the method and type in perimeter, and again I will tap down or press enter to create indentation. And for the perimeter, again, I want it to return 4 times the value that was provided for the self dot underscore side. So whatever value you provide for the sides, okay, of the square, it will multiply that by 4. Should be able to instantiate my square class, which has no abstraction methods. All right, so I'm just going to save my file. My square class takes in one argument, which is the side here. You can see here on line 12, I've got this variable called side. So that's the argument I've passed in for that parameter, which is 5. Okay, so if I play my file here, I don't expect to see any error. You can see there's no error here, which means that that class here on line 22, the instantiation has been successful. That's because of the implementation of the parent method inside the subclass. So the abstraction does not affect this subclass. However, I will still not be able to create an instance of the parent class because of the abstraction that is in place. Is calculate the area and the perimeter of the square object that I have instantiated on line 22. Before I do that, I just want to make some modifications here to my variable name. You can see here I've added underscore underscore side and here underscore underscore side. So on line 12 here, I need to add an underscore. So I'll do double underscore, which is underscore underscore, and that will keep that in line with the other variable names. So now that I've done that, to calculate the area and the perimeter, and just going to use the argument I have passed in on line number 22, which is 5. Yeah, so to do that, I'm just going to wrap it around a print function. So I'm going to do print, and inside that print function, I'm going to reference the name of my instance, which is called my square. So I'll do my square, and then to access the method in the class, you do a dot followed by the name of the method, which is called area. I'll add the parentheses, and then I'll tab down. I'll do the same. I'll do a print, and inside that print function, I'll reference my instance, which is called my square, and then use the dot to access the method called perimeter, and I'll add the parentheses for that. I'll just do a save, and what this print function should do on line 24 and 25 will print out the value. So to calculate the area, when the class was instantiated, I passed in an argument of 5 for this parameter called side on line 11. Okay, now that will multiply, as I've said in the method, by itself. So I've supplied 5 here, so it will multiply it by 5, which should give me 25. Now for the perimeter method here, I've specified a return of 4 times whatever argument I supplied for the side parameter. So here I supplied 5, so it will be 4 times 5, and that will give me 20. So let me play the file, and then you can see the output. So I click on play, and you can see here it's giving me 25 for the area and 20 for the perimeter, because I've specified that inside the method. So that concludes the video series on abstraction. So you were able to see how abstraction was implemented. When there's an abstraction in progress, you will not be able to instantiate a class due to the abstraction. So that's it for this video. Thank you for watching, and bye for now.